Hello students, how are you? Doing well? Very good. Dear students, we have been learning very important organic chemistry chapters. In this series, we have completed alcohols, phenols and ethers chapter. Before that, we have completed basics of organic chemistry, hydrocarbons, followed by haloalkanes and haloarenes. Dear students, let us see the exercises of alcohols, phenols and ethers. Dear students, in your textbook of NCERT, some of the answers were not given for the exercises. Some of them are given in your textbook at the end of your NCERT textbook as answers. However, I have prepared in detailed explanation answers for those exercises. Answers were not provided by NCERT, and it is observed that most of the times the questions which were not answered in the textbook are getting in your public exams, that is board exams, as well as in your entrance exams like JEE and NEET. So the more concentration is given in this explanation on the questions which were not answered in your textbook. Dear students, if you want to download, I am going to give the link at the end of this video. So please watch till the end of this video so that you will get the link how to download the PDF of all these exercises. And during this video, if you have any doubts regarding this chapter or previous chapters, you can write the question or write in comment box so that I will answer your questions. Dear students, please subscribe my channel Venus Academy if you are not yet subscribed, and don't forget to click on like button and bell button. Dear students, let us see the questions. Yes, the first question is write IUPAC names of the following compounds. Yes, the first question is the 2,2,4 trimethyl pentane 3-al. So it is the first principle of IUPAC nomenclature is choose the longest chain. So what it is, while you numbering the chain, so start from the side where the substituents gets least number, and this is the way to give the number 1, 2, 3, 3-al and 4. Yes, 5. So it is a 5-membered alkane. So it is pentane, and 2, 2, 4. The maximum number of substituents are on 2, 2 and 4, and the number is getting like this 2, 2, 4. So 2, 2, 4 trimethyl 3-al. It is not correct of numbering from this side 1, 2, 3 and 4. Dear students, this is not correct because it is getting alcohol is 3 number, no doubt, but the dimethyl group is on 4th number. Yes, so whereas dimethyl is number of methyls are more, are highly substituted carbon, and total number of substituents numbering should be lower. So that is why 2,2,4 trimethyl pentane 3-al. The next one 5-ethyl pentane 2,4-dial. All these answers are given in your textbook, students. So I am going to stress or going to focus on the answers those which were not given in your textbooks. Let us focus on them. So butane 2,3-dial, just check the answers, and these are also write IUPAC names. What is there? So phenols IUPAC name 2-methyl-phenol, it is directly given in your textbook during your explanation. Yes, so what is the common name of this? Orthocresol. Sometimes it may be asked what is the right? Orthocresol. Yes, student. So this is cresol, and this is paracresol. This is 2,5-dimethyl-phenol. This is 2,6-dimethyl-phenol. Like this you can give the nomenclature. So all these nomenclatures were given in your textbook. Please go through these and write structures of the compounds whose IUPAC names are as follows. So this is the way, if you have the name you can write the structures. So 2-methyl-butane 2-al. So this is 2 all, and this is 1 phenyl propane, 1 all, and 3,5-dimethylhexane, 1,3,5-triol. This is how you can write the structure, students. And all these answers are available in your textbook. I am going to focus on the questions which were not answered in your textbook. Yes, students. So it is not given the answers. Classify the isomers of alcohols in questions 11.3. So the questions are like this. So draw the structures of all isomers or alcohols of molecular formula C5H12O and give their IUPAC names. Yes, students. So C5H12, so usually it is pentane 1-al. Yes, it is alcohol. What is the alcohol formula? CN H2N plus 2 and O. Yes, so 5 to the 10 plus 2, 12 and O. So it is a saturated and alcohol. The common molecular formula shows it is an alcohol. So write the alcohol. So pentane 1-al you can write, 2-methylbutane 1-al write, 2,2-dimethyl 1-al, pentane 3-al. These are all isomers, students. So pentane 2-al, like this you can write how many isomers are possible for this. 1, 2, 3, 4, 5, 6, 7, 8 isomers are possible. So like this you can write the isomers. And the second question is classify the isomers of alcohols in question as primary, secondary and tertiary alcohols. Dear students, while explaining the chapter, I have given how to identify. So let us see what is primary and secondary alcohol. So this is primary alcohol and this is primary alcohol. This is also primary alcohol. This is secondary alcohol. So this alcohol is secondary alcohol. So the name itself, it says 2-al, right? So this is secondary alcohol. How to nomenclate or how to identify whether it is primary, secondary or tertiary? If the hydroxy group attached to carbon is attached to 2 carbons, then it is secondary. If it is attached to only 1 carbon, then it is primary. Let us see, this is the alcohol, it is tertiary. Right, alcohol is attached to this carbon. This carbon is in turn attached to 3 carbons, 1, 2 and 3 carbons. So it is tertiary carbon, tertiary alcohol, and this is primary alcohol. Yes, so this is how you can identify, and it is not given in your textbook. Dear students, if you have a question, you can write in comments box. Next, explain why propanol has higher boiling point than that of the hydrocarbon butane. Yes, hydrogen bonding in propanol, whereas in butane there is no hydrogen bonding, isn't it? Hydrocarbons don't have oxygens, alkane, alkene, alkynes and even benzene also. At the same time, alcohols are comparatively more soluble in water than hydrocarbon of comparable molecular mass. Explain the fact. Hydrogen bonding between alcohol and water molecules at the same time. So hydrogen bonding makes the compound, for example, this is an alcohol. It is, for example, ethanol. It is alcohol which is taken by some people, is soluble in water. So this way you can remember the answer also. So water and alcohol. Why it is miscible? So because the hydrogen bonding between these two. So this is the hydrogen bonding of alcohol oxygen and water hydrogen, and here this hydrogen can have bond with another alcohol, at the same time this oxygen is going to have hydrogen bonding with OH of alcohol. Like this, it is a chain like hydrogen bonding, a tightly intermolecular hydrogen bonding is going to take place. That is why alcohols are soluble in water, whereas hydrocarbons are insoluble in water. Next, what is meant by hydroboration? It is not given in your textbook. Hydroboration and oxidation reaction. Illustrate with an example. Dear students, this is the way I have explained during the video lecture on these alcohols. Yes, So what is the hydroboration? Hydroboration, let us take for example propene. If I take propene, this is propene. So propene undergoes hydroboration, and this hydroboration is anti-Markovnikov's. Anti-Markovnikov's addition takes place to give anti-Markovnikov's alcohol. So hydroboration gives anti-Markovnikov's alcohol. Yes students, so this is anti-Markovnikov's alcohol, where the first step is it undergoes syn addition. Syn addition means the hydrogen and borane adds from the same side to give this borane, and this borane further adds to another molecule of alkene to give diborane of alkyl diborane. This alkyl diborane adds to another molecule to give trialkyl borane. Trialkyl borane, when it is treated with hydrogen peroxide in presence of base, it takes a OH molecule to rearrange to this trialkoxy borane. This trialkoxy borane upon hydrolysis loses alkyl group as alcohol. Primary alcohol is going to be obtained, and this borane is going out as boron trihydroxide. So this is borane and oxidation. Hydroboration, this is hydroboration first step, and the second step is oxidation using hydrogen peroxide in presence of sodium hydroxide is known as oxidation. Next, give the structures on IUPAC names of monohydric phenols. Just now I have explained. Monohydric phenols means phenol will have only one hydrogen hydroxy, that is phenol, and the molecular formula is this C7H8O8. So C7H8 means there is another one methyl group, right? So C7H8 you can write it as cresol. Just now what I said, orthocresol. This is methyl is ortho position, and this is metacresol, and this is paracresol. Methyl is at para position, and phenol with respect to phenol. So the 2-methyl phenol, 3-methyl phenol, 4-methyl phenol. These are the IUPAC nomenclature. For your understanding, I have explained these catechol, dihydroxy compounds also catechol, resorcinol, quinol, and trihydric phenols, pyrogalal, fluoroglycinol, and quinol. Yes, so monohydric, dihydric, trihydric. Yes students, so this is the way. The common names are phenol, orthocresol, metacresol, and paracresol. And here dihydric phenols are catechol, resorcinol, and quinol. Trihydric phenols, it is pyrogalal. It is very very important students to know the common names: pyrogalal, fluoroglycinol, and 3-hydroxyquinol. Yes students, so this is how you can give the nomenclature to phenols. Then how to number? Start the numbering from phenol group. So 1, 2. So that is why 2-methyl phenol here, 3-methyl phenol here, 4-methyl phenol. Next, while separating a mixture of ortho and para nitrophenols by steam distillation, name the isomer which will be steam volatile. Give reason. Dear students, I have explained in detail. Steam distillation, how will you do? So upon nitration you are going to get the mixture of ortho and para. So this is ortho, and this is the para compound, which is major. Para compound is going to be major. However, while doing steam distillation, what is going to happen? So steam will be pumped into the mixture. This mixture is taken in a round bottom flask, having this nitrophenol. Into this steam will be pumped. So there will be a steam generator where water will be taken. In that water is heated to give steam. That steam will be pumped into the mixture of these two. And among these two, ortho and para, ortho compound is going to be low volatile because it is having hydrogen bonding. This ortho nitrophenol is going to have hydrogen bonding, and it is like hook like structure where this ortho nitrophenol comes out first along with steam. First comes out. So it is steam volatile. First steam volatile is ortho compound. Then At the end, after the finishing of this ortho compound, you are going to get para compound. So latter. So para is going to come out after latter stage. Yes. So this, it is coming first. What is ortho is coming first, and this is latter. That means after completion of ortho compound, para compound is going to be distilled out. This is how it is going to come out. Give the equation of reactions for the preparation of phenol from cumene. Yes students, so in your textbook the preparation method is given, but there is no mechanism is given in your textbook. So that is why I have explained along with mechanism during the video lecture. Yes students, so cumene, this is cumene. What is cumene? Isopropyl benzene is cumene. This hydrogen is highly acidic or labile hydrogen, because the intermediate what is going to be formed is tertiary free radical, which is stable free radical. So this cumene upon aryl oxidation gives hydroperoxide. This structure also is very important students. Cumene hydroperoxide structure. You may be asked the intermediate structure even in your board exams. At the same time, you may be asked in JEE mains and NEET and other entrance exams, even IIT JAM entrance exams. So this hydroperoxide upon hydrolysis gives phenol and acetone. Acetone also is obtained from this cumene, which is very important industrial solvent. Yes, ketone. This is ketone. So what is the mechanism? The first step is the cumene undergoes aryl oxidation by losing homolysis of this CH bond. Homolysis means homolytic cleavage takes place. This homolysis has to be written with half fish hook. So it is going to form two free radicals. This is hydrogen free radical and cumene free radical. Cumene free radical, in presence of cumene free radical, oxygen undergoes homolysis to give free radical. So this is also free radical to give cumene hydroperoxide free radical. This free radical now takes up this hydrogen free radical to give this cumene hydroperoxide, which is actually intermediate. This can be isolated if you want. So this hydrogen peroxide or cumene hydroperoxide intermediate, this is cumene hydroperoxide intermediate, upon hydrolysis in presence of acid. So the first step, since it is hydroperoxide, it is having lone pair of electrons. It easily gives up this lone pair of electrons, forms oxonium ion with H plus ions. So this is oxonium ion. So the first step of this stage is, since it is positively charged oxygen, it rearranges to this water molecule, and total this benzene ring is going to be migrated onto electron deficient oxygen to give, this is the intermediate. Dear students, so this mechanism is very important to give this carbocation. Now this carbocation takes up water molecule to give this. So here oxygen is attached here. At this stage it is going to lose H plus ions, or this tautomer, this hydrogen is going to be rearranged onto this phenolic oxygen, where at this stage it is having positive charge. It is going to lose as acetone. This is phenol. This is how you can prepare phenol and acetone. Yes, students, so the same thing is explained during the video lecture also. Right, next, write chemical reaction for the preparation of phenol from chlorobenzene. Dear students, it is not easy to prepare phenol from chlorobenzene. However, if you want to prepare, it is the reaction of nucleophilic substitution reaction. Nucleophilic substitution reaction and phenol, it is very tough. However, it is possible at high temperature. High temperature, dear students, already have said. So this is 350 degrees centigrade is very high temperatures. In your textbooks it is given as 350 plus 273. That means Kelvin scale. It is going to be like this. So if I write in Kelvin scale, just add 273, it is going to be 3 and 12 means 623 degrees centigrades, like that. So average 623 or 620 degrees centigrades means it is very high temperature. However, I am following this degree centigrade scale because you know the temperature of ice, it is going to be 0 degrees centigrades, and you know the temperature of boiling of water, it is 100 degrees centigrades. So you can imagine what is the temperature it is going to be followed during this reaction. 350 degrees centigrades means it is very high temperature. So at high temperature, chlorobenzene, for example, undergoes nucleophilic substitution with sodium hydroxide, that is OH is going to be substituted. This is OH is a nucleophile. At under ordinary conditions, nucleophilic substitutions on benzene are not possible. However, under drastic conditions like high temperature and the high pressure, it is very high pressure, students. So 300 atmosphere, what is the pressure of RT, room temperature? It is 1 atmosphere. So under very high pressure and at high temperature, chlorobenzene is going to give phenol. However, at ordinary temperature and pressures, it is not possible to prepare this phenol from chlorobenzene. So once it is substituted with sodium oxide or sodium salt, so you are going to get, as since it is having base, it forms base salt with sodium hydroxide, you are going to get a sodium salt of this phenol. When you treat it with, acidify it with HCl, you are going to get phenol. Yes, students. So in this slide you are going to get another method of preparation where it is high yields are going to be obtained by starting from benzene, do the first sulfonation using oleum. This sulphonic acid easily replaces with sodium hydroxide at around 100 degrees centigrades, and this way is very high yielding method from sulphonic acid. And another method is known as from diazotization starting from aniline, and this is also a very tedious process. Yes. So however, if you want, you can prepare from diazonium salts and from benzene. Next, write the mechanism of hydration of ethene to yield ethanol. This is one of the commercial methods for the preparation of ethanol. Now ethanol has been prepared starting from ethene. Alkene undergoes hydration in presence of acid. Yes, so this is a mechanism where hydration takes place. This double bond takes a proton to give intermediate of this carbocation. Let me write. So if it is ethene, it is going to form H plus. So this is hydrogen is already here, and it is having 3 hydrogens here. Ethene upon taking hydrogen, so this is electrophilic addition takes place first. So alkenes always undergoes electrophilic addition reaction, right? So this is the carbocation. This carbocation will take nucleophile of OH. So this is how you are going to get ethanol. Yes, students. So the mechanism, if I take with propene, where it is unsymmetrical, so this unsymmetrical alkene gives Markovnikov's product. Yes, so the mechanism is explained here. Anyhow, the question is how to do the hydration of ethene to ethanol. If you want, you can watch that video. I am going to give the link below of this video. It is given that alcohols, phenols and ethers. So complete one shot videos were made on explaining on whiteboard. Yes, students. Next, you are given benzene. Yes, we have benzene, concentrated sulfuric acid and sodium hydroxide. Write the equations for the preparation of phenols using these reagents. Yes, so concentrated sulfuric acid or oleum is nothing but H2S2O7. So fuming sulfuric acid easily sulfonates to give sulphonic acid. Benzene is going to be converted to sulphonic acid. This sulphonic acid upon nucleophilic substitution using NaOH, concentrated sodium hydroxide, gives sodium salt of phenol. This sodium salt of phenol upon hydrolysis, upon acidification with HCl, we are going to get this OH. that is phenol. So I have a question. If I ask you to make from phenol to benzene, what is the reagent? Do you remember how to reduce this? Just add zinc powder, zinc dust. So from back reaction, it is option is zinc, where it is going to lose as zinc oxide. Yes, so this is how you can do from benzene to phenol, phenol to benzene, like using zinc also. Right, next. So carry out sulfonation followed by nucleophilic substitution. Show how will you synthesize 1-phenyl ethanol from a suitable alkene, cyclohexyl methanol using an alkyl halide by an SN2 reaction, pentane 1-ol using a suitable alkyl halide. Dear students, so this is the way. H plus and water. So hydration, it is Markovnikov's addition. Yes students, so the first step is it is going to take a proton to give the intermediate of secondary carbocation, where benzylic carbocation is going to be formed. So this is CH, it is going to form CH and CH2, and hydrogen is added now. So now what is left over in the reaction mixture? OH. So OH will attack onto this to give 1-phenyl ethanol. So it is the 1-phenyl ethanol they are asking. So it is 1-phenyl ethanol. Then what is their cyclohexyl methanol using an alkyl halide by an SN2. So this is very simple students. So what is the reaction? It is SN2 reaction, right? And the next one is pentane. So pentane 1-ol using a suitable alkyl halide. So these answers are given in your textbook. I am not going to in detail. Next, give two reactions that show the acidic nature of phenol. Compare acidity of phenol with that of ethanol. Explain why is orthonitrophenol more acidic than orthomethoxyphenol. Reaction with sodium and sodium hydroxide I have given due to electron withdrawing effect on nitro group and electron releasing effect on methoxy group. Dear students, so exact nature of this phenol. Phenols are highly acidic. What is the overall acidity order of carbonic organic molecules? If you remember, carboxylic acids are highly acidic. Followed by phenols. I have been repeating this. Phenols. Then follows alcohols. So in between these two alcohols and phenols, water will come, students. So water is more acidic than alcohols. Then alkynes. So if I write the pKa values of these compounds, carboxylic acid's pKa values are 0 to around 8 pKa values, and if you remember, the lower the pKa, higher the lower the pKa value, stronger the acid. So phenols pKa value is around 10 and alcohols is around 15 and alkynes is around 20. And what is the pKa of water? It is 14. Yes students, so phenols are 10 pKa. If I substitute phenol with nitro group, and we have learned that electron withdrawing groups on phenol ring or benzene ring increases the acidity of phenols, and electron donating groups decreases the acidity of phenols. So nitro group is electron withdrawing group, so it is going to increase the acidity of phenol. If it is ortho position, the effect is more, at the same time para position. Ortho para nitro compounds or nitrophenols are more acidic than metaphenols. And one more thing, if the phenol is substituted at 3 positions, that is ortho, para and ortho, this is, I am going to explain, picric acid. Though it is not an acid, trinitrophenol. So this is nitro here, ortho nitro, and here another nitro, 2, 4, 6 trinitrophenol. Trinitrophenol is not an acid, but since it is having highly acidic in nature, it is also known as picric acid. So do you know what is the pK value of this? 0.38. So it is strong acid. Yes students, so picric acid is going to be acidic because of electron withdrawing nature of these nitro groups. Why this nitro group is going to make phenols more acidic? Because during the resonance structures, the phenol oxygen and phenol ring is going to get double bond character, and the carbanion which is going to be formed on benzene ring will be shared or withdrawn by nitro group. Yes, so that is why phenols substituted with nitro group are going to be more acidic than usual phenol. At the same time, the question is explain why ortho nitrophenol more acidic than ortho methoxyphenol. What is methoxyphenol? Methoxy group is electron donating group. What I said, electron donating group decreases the acidity. Yes, so that is why methoxy group is electron donating group or electron releasing group. That is why methoxyphenol is going to be less acidic than nitrophenol. Next, explain how does OH group attached to a carbon of benzene ring activate it towards electrophilic substitution. Yes students, just now I have been saying. So these are the resonance structures. Based on the resonance structures, electrophilic aromatic substitution takes place on ortho and para position in phenols. It activates ortho and para positions. Phenols are ortho para directing groups. So these are ortho para directing groups, and if you take this electrophilic substitution, yes, we know that what are the steps involved in electrophilic substitution step. It is generation of electrophile and formation of carbocation or sigma complex, then removal of hydrogen from sigma complex. This is how electrophilic substitution takes place. So towards electrophilic substitution. While electrophilic substitution, if I write the resonance structures of phenol, so what are the positions? It is ortho, it is getting carbanion, and para position it is getting carbanion. The ortho position are two sides ortho students. Yes, so you can write either of these two sides. Usually we write ortho substitution at right side. Yes, it is the common trend of writing. However, even if you write at left side, it is also correct, right? So this is how resonance structures of phenol is going to make more stable than this simple phenol. So that is why it easily loses H+ ions to get more stable structures of this O negative. So how many structures are possible in simple phenol? It is going to have attain only 3 structures, whereas this, after losing H+ ions, it is going to have more structures of resonance structure, that is 4 structures. Yes. Next, give equations of the following reactions. Oxidation of propanol with alkaline KMnO4. Alkaline KMnO4 is a strong oxidizing agent. It makes propanol to carboxylic acid and bromine in CS2. So bromine in CS2, what is going to be there? It is straight away given in your textbook. It gives ortho and para only one bromo. Yes. So what is the major product? Bromo. Major product is para. Why? So substituting at ortho position is not that easy, because already hydroxy group is, bulky group is here, and incoming bromine electrophile is going to be very big group. So this, because of this repulsion of this hydroxy group and bromine, the ortho position bromination takes place minor, whereas para position takes as a major. Dilute nitric acid with phenol. In this case also para is going to be major product. So here also para nitrophenol is going to be formed major because the incoming electrophile nitro group is very big, right? So dilute nitric acid gives only either ortho and para. If I use concentrated nitric acid and sulfuric acid and heat, I am going to get dinitro, at the same time picric acid, right? Treating phenol with chloroform in presence of aqueous NaOH. What is this reaction? It is Riemann-Tiemann reaction. We are going to get salicylaldehyde, and this salicylaldehyde you will get para hydroxybenzaldehyde also as some of the product. So the major product is salicylaldehyde. Ortho aldehyde takes place. Next, explain the following with an example. Kolb's reaction. What is Kolb's reaction? So phenol, upon treatment with sodium hydroxide, it forms sodium salt. This sodium salt is going to undergo electrophilic substitution at ortho position very easily. Why? It is salicylic acid, it is going to have ortho hydrogen bonding, so that is why it is going to form major. Dear students, yes, in previous example also it is going to form ortho as a major because of hydrogen bonding between nitro and hydroxy group. Yes. So this carbon dioxide, what is the is it electrophile or nucleophile? Carbon dioxide, it is a neutral nucleophile. However, in presence of this phenol, it is going to act as electrophile. It accepts this. So electrophile is going to take up this anion to form phenoxide ion. Phenoxide ion, upon hydrolysis with HCl, it is going to form ortho-hydroxybenzoic acid. What is the common name of this ortho-hydroxybenzoic acid? It is salicylic acid. Where do you find this salicylic acid? Salicylic acid is used for the preparation of acetyl salicylic acid. That acetyl salicylic acid is nothing but aspirin. Next, Riemann-Tiemann reaction. That is why I didn't explain in previous slides, friends. So Riemann-Tiemann reaction, it is formylation, orthoformylation of phenol to give salicylaldehyde. Salicylaldehyde. You can prepare salicylaldehyde straight away from phenol using chloroform and sodium hydroxide or KOH. What is the mechanism? The first step of this reaction is it takes a proton by sodium hydroxide and then it further loses chlorine to give dichlorocarbene. It is one of the ways to prepare dichlorocarbene from chloroform. This dichlorocarbene adds to phenol, sodium phenoxide to give this dichlorocarbocation. This dichlorocarbocation takes up proton, loses proton to give dichlorophenol. This dichlorophenol, this step is usually you are not going to find in most of the textbooks or reaction mechanism books. So this dichlorocarbon takes up water molecule or undergoes hydrolysis to give dihydroxy compound. Gem diol is going to lose water molecule and to give, for example, this is a water molecule is going out to give aldehyde. So that is how you are going to get salicylaldehyde. Next, explain the Williamson synthesis. Williamson synthesis is one of the versatile methods for the preparation of ethers. So in this case, what is the key factor? You have to take tertiary or secondary part as alcohol and the primary part as alkyl halide. Yes. So what is the first step? It is going to form sodium salt of this alcohol and now it is going to substitute this methyl group with. So in one step it is going take place. So it is SN2. SN2 is going to be take place by in Williamson synthesis. However, there are drawbacks. What are the drawbacks? You may not use this tertiary alcohol part or tertiary group in this ether to make this methoxy tertiary butyl ether. You have to take tertiary butanol and methyl bromide. You are not going to take this side alcohol, that is instead of methyl bromide methanol and alcohol part as bromine. No, what happens, this tertiary butyl bromide is going to lose HBr to give propene to methyl propene as major product. So elimination takes place. So this is a small I can say drawback. Yes, I am going to give the drawbacks also. Next, explain the following with an example. Unsymmetrical ether. Unsymmetrical ether. So you can prepare unsymmetrical ethers by Williamson synthesis. It is the very common synthetic method where you can use methyl iodide and phenol. Now most of the reactions you can substitute the sodium with potassium carbonate. Simply take phenol in dry acetone and add potassium carbonate as a base. This potassium carbonate makes salt with phenol and add methyl iodide. This methyl iodide substitutes oxygen. So iodide goes out as, if I use methyl iodide, I am going to get sodium iodide to give this methoxy phenol, methoxy benzene, right? So Williamson synthesis is one of the best methods to prepare mixed ethers. Next, write the mechanism of acid dehydration of ethanol to yield ethane. Yes students, so this is the mechanism. So usually how will you do? So dehydration takes place at high temperature using strong acid like sulfuric acid. If I use a strong acid, sulfuric acid at 170 degrees centigrade, I am going to get alkene. So if it is propene, no need of this much strong acid. It easily loses water at 170 degrees centigrade, and I can use H3PO4 also. And secondary alcohols, whereas tertiary alcohols very easily loses water to give propene, because the intermediates what is going to form carbocation is more stable. So tertiary alcohols undergoes dehydration very easily compared to secondary, compared to primary. This order is very important students, right? So let us take tertiary alcohol and see the mechanism steps. So it takes up proton to give carbocation, oxonium ion. This oxonium ion loses water to give this carbocation. Carbocation takes up hydrogen from beta, this alpha carbon to give alkene. So if the question is ethanol, then simply take just in place of this methyl group write hydrogen, and remaining mechanism is going to be the same. Next, how are the following conversions carried out? Propene to propanol, it is given in your textbook. Benzyl chloride to benzyl alcohol, ethyl magnesium chloride to propane 1-ol, methyl magnesium bromide to 2-methyl propane 2-ol. Yes students, so this is Grignard reaction. Benzyl chloride is substitution and hydration of propene. Next, name the reagents used in the following reactions. Yes students, oxidation of primary alcohol to carboxylic acid. What is the best methods? Potassium dichromate you can use, or neutral acidic alkaline potassium permanganate. So this is very strong oxidizing agent where alcohols undergoes over oxidation to give carboxylic acids. And oxidation of primary alcohol to aldehyde. So this is pyridinium chlorochromate in dichloromethane. What is the reagent? It is Jones reagent. Next, bromination of phenol to 2,4,6-tribromophenol. What is the reagent? Bromine in water. Then benzyl alcohol to benzoic acid. Benzyl alcohol to benzoic acid, it is strong oxidizing agent is required. Alkaline potassium permanganate you can use to give this benzene to benzoic acid. Dehydration of propane 2-ol to propene. So 85 sulfuric acid or H3PO4 also is enough. And butane 2-on to butane 2-ol. Tanninickel hydrogenation, or ketone to alcohol, you can use sodium borohydrate or lithium aluminum hydride, reduction of ketones. Next, give reason for the higher boiling point of ethanol in comparison to methoxymethane. So methoxymethane is going to have low boiling point than ethanol. So ethanol is going to have more boiling point because of alcohols are going to have more boiling point because of intermolecular hydrogen bonding. Alcohols are going to have hydrogen bonding, whereas ethers do not have no hydrogen bonding. Ethers, there is no hydrogen bonding. Alcohols are going to have hydrogen bonding. That is why alcohols are going to have higher boiling point than ethers. So usually ethers, what is the boiling point? Ethers boiling points are more or less same, nearly comparable to hydrocarbons. Whereas, for example, if I take pentane, the boiling point of pentane is 36 degrees centigrades and the boiling point of this diethyl ether is 32 degrees centigrades and N-butanol is 113. So alcohol's boiling point is very high because of hydrogen bonding, whereas ethers do not have hydrogen bonding, so their boiling point is lower than the alcohols. The straight away answer is because of hydrogen bonding is ethanol, it is going to have higher boiling point. Methoxymethane, there is no hydrogen bonding, so lower boiling point. Next, give IUPAC names of the following. So here ethoxy group, the question is ethoxy and dimethyl, which is going to have priority. The numbering has to be followed from this side, students. 1, 2, 3 and 4. So this is a question. Actually it should be like this. Ethoxy oxygen should get priority. So that is why it is given from 1-ethoxy 4,4-dimethyl. Next, write the names of reagents, equations for the preparation of the following ethers by Williamson synthesis. 1-propoxypropane. So how to prepare? 1-bromopropane and sodium propoxide. Then ethoxybenzene. How to prepare ethoxybenzene? Ethyl bromide you have to take. 2-methoxy-methylpropanone. Yes. So sodium methoxide, bromomethane you will get 1-methoxyethane. Next, illustrate with example limitations of Williamson synthesis for the preparation of certain types of ethers. Dear students, just now I have explained mixed ethers can be prepared. Versatile method is Williamson synthesis by taking alcohol. So mixed alcohols, it should be aryl part or alkyl, which is going to be secondary or tertiary, has to be taken as alcohol part, whereas the other part is going to be taken as halide part. If I take this tertiary or secondary alcohol as halide, it is going to give alkene as major product because of elimination reactions. So that is why the limitations are tertiary halides or secondary halides are not used as substrates because they result elimination product. At the same time, aryl or vinyl halides cannot be used in Williamson synthesis because they are less reactive in nucleophilic substitution reaction. This is a small limitation of Williamson synthesis. Next, how is 1-propoxypropane synthesized from propane 1-ol? Right mechanism of this reaction. Dear students, it was asked in your board exams. Please go through this. It can be prepared in two ways, right? So propane 1-ol, you can make it as bromopropane by treating with phosphorus tribromide. This phosphorus tribromide and another molecule of propane 1-ol, it gives sodium salt, and sodium salt of this and this upon Williamson synthesis you are going to get propoxypropane. However, there is straight away propoxypropane method also is there, treating dehydration of alcohols to get ethers. So it is a simple ether, symmetrical ether. You can treat it with propanol with acid to lose water to give straight away propoxypropane. Yes friends, so this is how you can prepare. Next, preparation of ethers by acid hydration or of secondary or tertiary alcohols is not suitable. Why? Just now I said it is going to form this alkene part. Yes students, next, Write the equation of reaction of hydrogen iodide with 1-propoxypropane, methoxybenzene and benzyl ethyl ether. So propoxypropane, how will you prepare? Reaction of hydrogen iodide. Hydrogen iodide, where it is going to break? Yes students, so primary alcohol part is going to take up iodide. In this case methoxy, where it is going to get, is it going to break at this position iodide? No. So it is going to break this side, so it is going to have methyl iodide. And in this case, so there are two chances, it is this side and this side. Which is going to get iodide part? So it is going to take up this iodide part, because benzyl carbocation is more stable, so it undergoes SN1 mechanism to give benzyl iodide and ethanol. It is very important concept students. So benzyl ethyl ether, benzyl ethers takes up this iodide group. So that is why, so benzyl ethers can be cleaved. So this is common procedure. If I have phenol, I can make benzyl ethers. Benzyl ethers, I am going to ask the same question in a different way. So write down the mechanism or write down the products of this ether, where it is going to break. Is it going to break here or here by using HI? Yes friends, it is going to break here, HI. So I am going to get benzyl iodide, and this side it is going to get phenol. So protection, deprotection, it is also one of the ways to make benzyl ethers and debenzylation. Next, explain the fact that in aryl alkyl ethers, the alkoxy group activates the benzene ring towards electrophilic substitution, and it directs the incoming substituents to ortho and para position in benzene ring. So aryl alkyl and aryl ethers, what is going to happen? So it is very simple students. If I write the resonance structures, it is the position, ortho position getting carbanion, para position is getting carbanion, and this is also ortho position. So ethers, ortho para directing groups. And if I write the mechanism, electrophilic substitution involves 3 steps. The first one is generation of electrophiles, second step is formation of carbocation or sigma complex, and third step is removal of hydrogen. Next, write the mechanism of the reaction of hydrogen iodide with methoxymethane. Methoxymethane, what is going to happen? It is going to give methyl iodide and water. Since two sides it is methoxymethane, so it is going to give methyl iodide and water. So iodination or alkylation, the formed alcohols also takes this halogen. Halogenation of alcohols takes place in presence of HI. So the end product is methyl iodide. Write equations of the following reactions: Friedel-Crafts reaction, alkylation and of anisole. Alkylation of anisole, this is anisole students. So that is why while explaining the structures, this is methoxybenzene is also known as anisole. Anisole upon treatment with methyl bromide in presence of anhydrous aluminum chloride, it is Friedel-Crafts reagent. Lewis acid, carbon disulfide is a solvent where its boiling point is around 50 degrees centigrade. At low temperature gives ortho and para mixture. Yes students, so we are going to get ortho para mixtures. Again the mixture can be separated by steam distillation. Acetylation also takes place in a similar manner using acetyl chloride. Yes students, next, write the nitration of the following reactions. Nitration involves how many steps? So since it is electrophilic substitution reaction, it involves 3 stages: generation of electrophile, formation of sigma complex, removal of hydrogen. Dear students, you may be confused how to generate nitronium ion. Nitronium ion, this is NO2 plus, is electrophile. It forms by losing H2O molecule, H2O water molecule from HNO3. In this case, sulfuric acid is going to act as acid and this HNO3 is going to act as base to form electrophile of NO2 plus. This NO2 plus will undergo nitration in presence of anisole, right? So this is the way. If I use nitrating mixture, I am going to get orthopara mixture, and if I heat it, it is going to form trinitrophenol, that is picric acid. And if it is anisole, only nitration, dilute nitric acid. Since it is not given, I have taken concentrated. So if it is not given, if I take dilute nitric acid, I am going to get only ortho or para mixture. So next, write the bromination of ethanoate anisole in ethanoic acid. Dear students, ethanoic acid, the common name of ethanoic acid is acetic acid. It is a little bit confusing. So ethanoic acid, acetic acid. So bromine in acetic acid, alkyl aryl ethers are strong enough to activate this phenol ring. So this phenol ring is strong enough to activate phenol ring towards electrophilic substitution. So in this case, use of this ferric bromide also is not required. So usually bromination of aromatic compounds requires Lewis acid for the formation of electrophile, but this, in presence of this strong activating group like ethers or phenols, so bromine doesn't require Lewis acid to undergo bromination of phenol. So in this case, bromine in acetic acid, it undergoes bromination even without using ferric bromide. In this case, acetic acid itself is going to act as acidic medium or catalyst to undergo this bromination to give para and ortho substituted compounds mixture of phenol ethers. Next, write equations of the following reactions. Friedel-Crafts acetylation of anisole. Just now I have explained. So acetylation takes place by using acetyl chloride. Yes, so that is how you will get mixture of ortho and para mixture. Simply write ortho and para. If you are not sure about the mixture, what is major and minor, simply stick to this para position. Para compound is going to form major in all reactions except nitrophenol. Yes students, remaining all, it is going to form para substituted product as major, because so the incoming this acetyl group is going to be bulky and this is also bulky. So a repulsion takes place between these two groups. So that is why para position is free to approach. So para compound is going to be formed major. Next, show how would you synthesize the following alcohols from appropriate alkenes. So alkene, it is, if I show how would you synthesize the following also from appropriate alkene. So this is alkene. So 1-methyl cyclohexene upon acid hydrolysis, it is going to form this Markovnikov's alcohol we are going to get. Yes students, so this is 1-methyl cyclohexene has to be taken as starting materials. And next, so in this case it has to be 4-methyl heptare 3N acid hydrolysis to give Markovnikov's product. These are all Markovnikov's products where we are going to get tertiary or secondary alcohols as major products. Next, show how would you synthesize the following alcohols from appropriate alkenes. Same question. So it is also pentatoluene Markovnikov's product, and this is also Markovnikov's product. Simply add, take the alkene and add alcohol or water. So what is going to happen? You may have question. If I take this side alkene, what is the product? It is going to form alcohol both side, because it is also tertiary, this is also tertiary, and you are going to get major like this. So that is why I have taken alkene at this side, right? Next, when 3-methyl butanol is treated with HBr, the following reaction takes place. So why and how? It is very simple students. The first step is going to, so this rearrangement is very very important and it has been asked in JEE Mains 2019 also, right? So what is going to happen? The first step is alcohol undergoes dehydration to give carbocation. What is the carbocation? In this case it is secondary carbocation. So secondary carbocation undergoes hydride shift. Hydride shift is going to take place. 1,2 hydride shift takes place. So upon 1,2 hydride shift, what is going to form here? It is tertiary carbocation. Tertiary carbocation is more stable than secondary carbocation. This secondary carbocation now takes up bromine to give this side a bromo compound. So this is how. So hydride shift is very, very important, students. So what is the migratory aptitude? Always migratory aptitude is more to hydrogen followed by other groups. For example, benzyl, allyl or alkyl groups. So give the priority to hydrogen shift. So don't shift this methyl group. Yes, even if you shift this methyl group here, you are going to get same this secondary type carbocation. So this is not the way. So shift or migrate this hydrogen to this secondary carbocation to get this product. Yes, students. So we have completed all the exercises of alcohols, phenols and ethers. I hope you understand these questions. If you have any questions while solving this paper, you can write in comment box, and I am going to give the link below of this video description to download these exercises with solutions. If you have any doubts, you can follow that. Yes, students. Thank you, students. Thank you for watching this video. Please subscribe my channel Venus Academy if you are not yet subscribed, and don't forget to click on like button and bell button. Thank you. Bye. Wish you all the best. All the best. Arigato gozaimasu. Bye.